NFPA 70 National Electrical Code, NEC, 2023, Section 310.9, Insulation of Conductors, Paragraph B, Mechanical protection of insulated conductors states insulated conductors shall be protected from physical damage by firstly, flexible or rigid conduit, secondly, tubing, and thirdly, approved enclosures. In other words, the insulation of neutral conductors must be protected from physical damage. While the NEC does not specify a specific length of exposed wire, it does require that the insulation be protected. Exposed neutral conductors can pose a safety hazard, as they could come into contact with other conductors or objects, potentially causing an electrical shock or fire. Bare neutral conductors can be subject to corrosion, which can weaken the conductor and reduce its lifespan. Failing to properly insulate neutral conductors can result in the installation failing code inspections and potentially being deemed unsafe for occupancy. The exposed neutral wire should be insulated to meet the requirements of the NEC. This can be done using a variety of methods, such as electrical tape, heat shrink tubing, and insulating covers. Electrical tape can be used to insulate the exposed wire. Heat shrink tubing can be used to insulate and seal the exposed wire. Insulating covers can be used to protect the exposed wire. While the NEC does not specify a specific length of exposed neutral wire allowed on a neutral bus bar, it does require that the insulation be protected from physical damage. Therefore, any exposed neutral wire should be insulated to ensure safety, prevent corrosion, and maintain code compliance. Let's delve deeper into the reasons behind these regulations and explore practical solutions for addressing exposed neutral wires. The primary concern with exposed neutral conductors is safety. Electricity always seeks the path of least resistance, and any exposed conductor presents a potential pathway for current to flow where it shouldn't. Contact with an exposed neutral wire can result in electric shock, which can range from a mild tingle to a life-threatening event, depending on the voltage and current involved. Furthermore, exposed conductors can create a fire hazard. If a conductive object accidentally bridges the gap between an exposed neutral and a grounded surface or another conductor, it can create a short circuit. A short circuit results in a rapid and uncontrolled flow of current, which can generate excessive heat and ignite nearby flammable materials. This is why proper insulation is so crucial in electrical systems. Insulation acts as a barrier, preventing unintended contact with conductors and minimizing the risk of electric shock and fire. In addition to safety concerns, exposed neutral wires are susceptible to corrosion. Corrosion is a chemical process that degrades the metal of the conductor, weakening it and reducing its ability to carry current. This can lead to increased resistance in the circuit, causing overheating and potential failure of the electrical system. The NEC emphasis on protecting conductor insulation is also driven by the need to ensure long-term reliability and prevent costly repairs. When insulation is compromised, the conductor is exposed to environmental factors like moisture, dust, and chemicals, which can accelerate degradation and reduce its lifespan. By maintaining proper insulation, we can extend the service life of electrical wiring and equipment, minimizing the need for replacements and reducing maintenance expenses. Now, let's explore some practical solutions for insulating exposed neutral wires. As mentioned earlier, several methods can be used to address this issue. Firstly, electrical tape is a readily available and cost-effective option for insulating small areas of exposed wire. However, it's important to use high-quality electrical tape that is specifically designed for electrical applications. Ensure that the tape is applied tightly and securely, overlapping each layer to create a waterproof and airtight seal. Secondly, heat shrink tubing provides a more robust and durable solution for insulating exposed wires. Heat shrink tubing is a type of plastic tubing that shrinks when heated, creating a tight and protective covering around the wire. To use heat shrink tubing, simply slide a piece of tubing over the exposed wire, position it correctly, and then apply heat using a heat gun or hair dryer. The tubing will shrink and conform to the shape of the wire, providing excellent insulation and protection against moisture and corrosion. Thirdly, insulating covers offer another option for protecting exposed wires, particularly in situations where taping or heat shrinking may be difficult or impractical. Insulating covers are typically made of plastic or rubber and are designed to snap or clip onto the wire, providing a physical barrier against contact. These covers are available in various sizes and shapes to accommodate different wire gauges and configurations. When selecting a method for insulating exposed neutral wires, it's important to consider the specific application and the environment in which the wiring is located. In damp or corrosive environments, heat shrink tubing or insulating covers may be the preferred choice due to their superior moisture resistance. It's also crucial to ensure that any insulation materials used are rated for the voltage and temperature of the circuit. Using the wrong type of insulation can compromise its effectiveness and create a safety hazard. In addition to properly insulating exposed neutral wires, it's also essential to address the underlying cause of the problem. In many cases, exposed wires are the result of improper wiring techniques or damaged insulation. If you encounter exposed wires, it's important to inspect the surrounding wiring for any signs of damage or wear. If you're not comfortable performing electrical work yourself, it's always best to consult with a qualified electrician. They can assess the situation, identify any underlying problems, and make the necessary repairs to ensure the safety and integrity of your electrical system. Remember, electrical safety is paramount. By following the NEC guidelines and taking proactive steps to address exposed neutral wires, we can create safer electrical environments for ourselves and others. While addressing exposed neutral wires is crucial for safety and code compliance, it's also important to understand the broader context of electrical grounding and bonding. The neutral conductor plays a vital role in a properly grounded electrical system, providing a return path for current and helping to prevent dangerous voltage buildup. In a typical electrical circuit, current flows from the source through the load such as a light bulb or appliance, and back to the source through the neutral conductor. The neutral conductor is typically grounded at the service entrance, which means it's connected to the earth through a grounding electrode. This grounding connection helps to stabilize the voltage of the electrical system and provides a low impedance path for fault current to flow back to the source in the event of a ground fault. A ground fault occurs when a live conductor comes into contact with a grounded surface, such as a metal enclosure or a water pipe. Without a proper grounding system, the fault current could flow through unintended paths, such as a person touching the grounded surface, resulting in a dangerous electric shock. The grounding system provides a safe path for the fault current to flow back to the source, tripping a circuit breaker or fuse and de-energizing the circuit. In addition to grounding, bonding is another important aspect of electrical safety. Bonding refers to the practice of connecting all metal parts of an electrical system together to create a common ground potential. This includes metal conduits, enclosures, and equipment frames. By bonding these metal parts together, we can ensure that they are all at the same voltage potential. This prevents voltage differences from developing between them, which could create a shock hazard if someone were to touch two different metal parts simultaneously. The NEC has specific requirements for grounding and bonding, which are outlined in Article 250. These requirements are designed to ensure that electrical systems are properly grounded and bonded, minimizing the risk of electric shock and fire. When working with electrical systems, it's essential to understand the principles of grounding and bonding and to follow the NEC guidelines carefully. Improper grounding or bonding can create dangerous conditions that could lead to serious injury or death. Furthermore, the NEC addresses specific requirements for neutral conductors in different types of electrical systems. For example, in a 3-wire, 120/240 volt single-phase system, the neutral conductor carries the unbalanced current between the two hot legs. In a 4-wire, 208Y/120 volt 3-phase system, the neutral conductor carries the unbalanced current between the 3 hot legs. The NEC specifies the minimum size of the neutral conductor based on the calculated load it will carry. It also requires that the neutral conductor be insulated, except in certain specific situations, such as when it's used as a grounding electrode conductor. In addition to the general requirements for neutral conductors, the NEC also addresses specific requirements for neutral connections at the service entrance and at branch circuits. At the service entrance, the neutral conductor must be connected to the grounding electrode system, which consists of a grounding electrode such as a ground rod or a metal water pipe and a grounding electrode conductor. The grounding electrode conductor connects the neutral conductor to the grounding electrode, providing a path for fault current to flow back to the source. At branch circuits, the neutral conductor must be connected to the neutral terminal of the receptacle or lighting fixture. This connection provides a return path for current to flow back to the panel board. The NEC also requires that the neutral conductor be identified by a white or grey colour. This helps to distinguish it from the hot conductors, which are typically black or red. When working with electrical systems, it's essential to follow the NEC guidelines for neutral conductors carefully. Improper neutral connections can create dangerous conditions that could lead to electric shock or fire. Remember that electrical codes and regulations are constantly evolving, so it's important to stay up to date on the latest requirements. Consulting with a qualified electrician or electrical inspector can help you ensure that your electrical systems are safe and compliant with all applicable codes. By understanding the principles of electrical grounding, bonding, and neutral conductors, and by following the NEC guidelines, we can create safer and more reliable electrical systems for our homes and businesses. Let's now consider some common scenarios where exposed neutral wires might be encountered and how to address them effectively. Firstly, during renovations or remodeling projects, existing wiring may be exposed when walls or ceilings are opened up. In these situations, it's crucial to carefully inspect the wiring for any signs of damage or deterioration. If you find any exposed neutral wires, they should be properly insulated before the walls or ceilings are closed up. Secondly, in older homes, the insulation on wiring may become brittle or cracked over time, leading to exposed conductors. This is particularly common in attics or basements where wiring may be exposed to temperature extremes or moisture. If you find damaged insulation, it should be replaced or repaired by a qualified electrician. Thirdly, improper wiring techniques can also result in exposed neutral wires. For example, if a wire connector is not properly tightened, the insulation may slip off, exposing the conductor. Similarly, if wires are pulled too tightly during installation, the insulation may be damaged. It's important to follow proper wiring techniques and to use the correct tools and materials to avoid damaging the insulation. Fourthly, in some cases, exposed neutral wires may be the result of accidental damage. For example, a nail or screw may be driven through a wire, or a wire may be cut or nicked by a sharp object. If you suspect that a wire has been damaged, it should be inspected by a qualified electrician to determine if it needs to be repaired or replaced. When addressing exposed neutral wires, it's important to follow a systematic approach to ensure that the problem is resolved safely and effectively. Firstly, turn off the power to the circuit, hit the breaker or fuse box. This will prevent electric shock while you're working on the wiring. Secondly, inspect the wiring carefully to determine the extent of the damage. Look for any signs of exposed conductors, cracked insulation, or loose connections. Thirdly, choose the appropriate method for insulating the exposed wire. Electrical tape, heat shrink tubing, or insulating covers can be used depending on the specific situation. Fourthly, apply the insulation carefully, following the manufacturer's instructions. Make sure that the insulation is tight and secure, and that it covers all exposed conductors. Fifthly, inspect the surrounding wiring for any other signs of damage or deterioration. If you find any other problems, they should be addressed as well. Sixthly, turn the power back onto the circuit and test the wiring to make sure that it's working properly. If you have any doubts about your ability to safely address exposed neutral wires, it's always best to consult with a qualified electrician. They have the training and experience to identify and resolve electrical problems safely and effectively.